Electrophilic substitution mechanism. Before I continue, I will want you all to know there are 5 reaction mechanisms that your syllabus say you need to know by heart. Each of them is 2 to 3 marks if they ask you, meaning you can even memorize and regurgitate. Very easy stuff. We have learned 2 of them. This is the 3rd one. See whether you agree. 1, 2, 3, 4. I'll be reminding you all over and over again so that it becomes habitual and you don't have to like go and memorize them. You automatically come to you. First one we learn is called free radical sub, where the topic is called alkanes. Next, we learn about electrophilic add, where we learn it in alkenes. Today, right now, we're going to learn about electrophilic substitution, short form, where Arenes. I actually wanted to leave it blank for 4th and 5th, but never mind, I let you know first. But I just let you know, you learn it only in J2, all right? About February to March, then I'll teach you. So we have a few more. It's called nucleophilic addition. Sorry, wrong already. It should be nucleophilic sub in terms of order and sub. This is something called halogenoalkenes or halogen alkenes. And the last one is called nucleophilic addition. It's under a topic, again, after the halogenoalkenes. It's called carbonyl compounds. So these are the 5 standard ones you can memorize and then you throw, close both eyes. Are there others? Yes, but those are plain, application-based. These 5 are not application. These 5, you know, a primary school kid can memorize and give it for 2 to 3 marks. Everyone okay? So where are we today? We are in here. All right, the 3rd one. Ready? Ladies and gentlemen, electrophilic substitution tells you you need to have an electrophile. So first step 1, is to what we call produce an electrophile. Production of the electrophile, E+. Now, let's recap what's electrophile. Electrophile means this is electron seeking, electron loving. Okay? Phile means love, right? So loving or seeking. They seek electron, they love electrons, which means they are what? They are electron deficient species. E+, desperate for electron. Obvious, they're cation. All by understanding. Okay, everyone? E+ is a cation. Cation is desperate for electron. Now, step 2 is the formation of carbocation intermediate. Where have we seen this word before? Alkenes. But it is a different structure. It's slightly different. So what is carbocation? Carbocation has no meaning. Basically, it tells you a carbon with a positive charge ion. Anything like this is called a carbocation intermediate. Carbocation intermediate has no much of meaning. It just tells you the carbon desperate for electron. Okay, C+. It can accept electrons. Okay, so it's again electron deficient. So it's desperate for electron. So it can accept electron. Ready? Next, I'll tell you where's the confusion, right? And MCQ, they love to play this. Listen closely. Okay, let me show you what's happening first. Ready? Follow me very closely. The E+ that you have created in step 1 will be here. Everyone okay? It's just a story. Follow closely. Anything that positive, desperate for electron, it is as good as saying it has an empty orbital. Everyone okay? Atomic structure is the first topic or second topic you learn in J1 for this reason. Everyone okay? You got an empty orbital. All cation, by right, have an empty orbital to accept something. Everyone okay? You learn this in bonding also. So benzene, remember, it has the triple double bond, yes? So keyword is very right, is electron rich. Everyone okay? You need electron, I have electron. You need money, I have money, I give you all. Make sense or not? Dative bonding occur. Remember the word dative bonding? Organic chem, every reaction is dative bonding, one way or another. Make sense? You got empty orbital, I have one lone pair, I shoot long. I give it to you. Done. You can't see this well, all right? Why? Because it was drawn in the resonance structure. Okay? I'm going to draw this out to show you in the what we call the Kerkulé structure, i.e. the structure with the double bond. See whether it's better. Right? This was the structure. Remember the alternating double bond? These are all H. Okay? Correct? That's what we have, right? So again, it is the double bond. But again, you don't know which double bond. Are you with me? So it's somewhere here, a combination of all three. The double bond, then go and attack the E plus. Okay? And then what you have is this carbocation intermediate. There's different looking, looks different from the one from alkenes. It looks like this. I have to emphasize a lot of things here which are heavily tested. It is drawn this way with a positive sign right in the middle. Okay, now why is it like that? Okay, let's use a bit of common sense. Are you all ready? Those I've taught you before since Sec 3 or if not Sec 1 until now, I've been talking about this. I always use this analogy. Ready? All right, so I will give you this example. If this is Sean Chua, benzene got no charge, i.e. I don't have no money in the bank, but I also never owe people money. Make sense, everyone? Very easy one. And this is my girlfriend. My girlfriend is 1 plus charge. She got $1. Make sense, everyone? So if we get married and we set up a family, or rather we get married, we are on this side. Agree with me, my friend? I is called my family. Don't you agree with me that 0 plus 1 plus is equals to 1 plus charge? Agree with me? $1. Everyone okay? I'm done. It has a positive charge. I is a cation. All right? Definitely is a positive charge. So first, everyone must agree there's a positive charge. All right? Next, where is the positive charge? On which carbon atom? Okay? The positive charge in a while, I'm going to show you, it is in the middle, which basically tells you the positive charge is shared between this, and this carbon atom. 5 carbon atoms. All right, which I have stated here. The positive charge spread around the remaining 5 sp2 carbon atoms of the ring. Note that it does not reside only on the sp3 carbon atom. So a lot of people think it's here, which is wrong. Everyone okay? Why? Because over here, it cannot have positive charge. There are 4 bonds there. Correct or not? 4 bonds on the carbon atom. Count, if you cannot count, I can help you already. Therefore, is neutral or no charge. So the MCQ 4 options, right? All of them sound the same. They are there to screw you up. They're there to confuse you. MCQ tests you on the basic stuff. These are the basic of the basic. That's why people are very scared of MCQ, including all the A students. Why? They know how to do difficult questions. But when they go to the basic, they don't know what is happening because they never ever drill into the basic. Yeah, we are here because we're aiming for A, full stop. If you're not here for A, then you don't have to be here. Can be achieved, all right? But you need to deep dive. And that's why do you realize we draw a circle that is not complete? So it encompasses the 5 carbon. Can you see? What it means, this one is actually, this is your double bond. Remember the resonance structure? Can you see now? Are there still resonance? Yes. Around here, there's still resonance happening, but never touch the carbon on top, the orange color. Make sense, everyone? There's still 2 double bond there. Do you realize that? Because 1 is used, got another 2 there. All right. So again, it is still resonance stabilized, but it is not aromatic anymore. Remember what's aromatic? Aromatic means a full benzene ring, which also means it has a triple double bond. It doesn't have. It only has like a 2 double bond. Make sense? Okay, okay, not done yet. We just started. Ready? You're happy with this, huh? Now you see, we just mentioned that it's definitely obvious that this is the arrow. Make sense? Okay. So in English, what will you call this? In English, listen carefully. MCQ test. In English, this sounds like that the benzene ring electron attack the electrophile. Agree with me? Right. This arrow sounds like what? Inverted comma. The pi electrons from the ring attacks the electrophile. Agree? Inverted comma. By right, huh? Then you realize, check your school notes. First, I show you my notes first. Ta-dang. Look at the English. By the attack of E plus on the benzene ring. In English, do you realize it's tombalik? Can you see it's opposite? Your English better than mine, right? There's nothing wrong here. There's no typo error. And this is how they write. Attack of E plus on the benzene ring. Meaning is the E plus attack the ring. This is the wrong English to use. Is E plus attack the ring. This is correct. Am I okay? But why like that? The arrow doesn't show like that. Right? Welcome to organic chemistry. In fact, welcome to chemistry. Ladies and gentlemen, if you are doing this reaction in the lab, may I ask you which is your main compound? The main one, and then you always add a reagent to react. Everyone remember? Understand? This is the main reagent that you add. The reagent, also known as the attacking reagent, is always based on what you add. Understand? To deal with the organic compound. That's why they always phrase it this way. What you add will react with the organic compound. Okay, because this is the organic compound. And then what you add will determine what reaction is it. All right, so it's an electrophile attacking it because you add something to attack the organic compound. All right, so be very careful. Your MCQ, they all sound the same, but they are not the same. All right, be careful. All right, so basically, if there's this reaction, then there's MCQ. If this is option A, right? Option A, true or false statement. This is not true. This is a false statement. A lot of people say this is true because they remember the pink color, but it's wrong. Be very careful. All right, so again, I've discussed this. What is it? The attack of benzene ring, can you see? By the electrophile on the pi electrons. The electrophile means the E plus. All right, I just discussed this. This is a correct statement, not this one. This step is the slow step. I.e. in kinetics, yes, we're in kinetics. Everyone should have learned kinetics in your J1. If not, your school syllabus is really messed up. They do it the wrong way, all right? Rate determining step. Why is it slow? Because it caused the destruction of the aromaticity of benzene ring. Again, let's use some common sense. You see, ladies and gentlemen, this is stable. Agree? Resonance stabilized. This is a cation. It is therefore unstable. All ions are unstable. Make sense? Common sense, who would want to be stable to become unstable? Not many people, right? I like to have a stable life. I don't like to every day cannot sleep, panic, what will happen tomorrow, tonight. Therefore, it's a slow step because we don't want to go through this step. Common sense. Science is based on common sense. Okay? So first step is a slow step. And the slow step, according to kinetics, is the rate determining step. So once you have this, the slow step, then we go to the third step. It's called the expulsion. So third step, expulsion of H plus from the intermediate to form the products and the delocalized pi system. So again, what happened here? Take a look at this bond, the hydrogen, right? There's 2 electrons there. Both the electrons then come in. All right, there's 2 electrons. So this thing will then fly off as H plus, correct? Which you've seen here. And therefore, what you get is this structure with the E attached to it. And again, this is the fast step. Why? Common sense. Positive charge, unstable, because it's an ion. Now it gets back the aromaticity and its neutral charge, obviously stable. Everybody will rush to become like that in life. Fast step.
If you would like to catch my latest videos, click on subscribe button right now. And click on the bell if you want to receive instant notifications once I've uploaded my latest video. If you would like to join my live chemistry classes and revision workshops, go on to winnerseducation.com and find out how you can score distinction for chemistry on a consistent basis, either in our center or online via Zoom. If you want to check out my online school, go on to passwithdistinction.teachable.com. You'll be able to learn chemistry concepts at your own pace and anywhere in the world, topic by topic. This is Sean Chua from Winners Education, to your distinction in chemistry.